This is Professor Derf Seitz. This video shows how to calculate a binomial distribution quota using Microsoft Excel. In this spreadsheet, there are 3 blue cells where you have to enter information. First, the probability of a success on any of the n trials. For this example, it's 85% entered as a decimal. You also need to enter your quota that you want. You want 3 successes out of the n trials. That's your quota. Desired minimum number of successes, at least 3. If you get more than that, that's fine. But you're looking for the minimum. And your level of confidence for this quota. There's a table down here. The first row takes, for n, in this column for n, takes the quota. If you look at the formula for this first row, it's just the quota that was entered. The other values of n just increment the previous row's value, so they're going up by 1. They just go down to here. If it needed to be extended, it could be extended more, replicated. The next column for each n calculates the mean of this distribution, which is the expected value n times p. So we have the expected values here. And the last column calculates the probability that the number of successes, x, will be greater than or equal to the quota, a probability. Looking at that formula, before we talk more about this first one here, we see the formula up here, and the idea shown in this example comment, we're looking for the probability that x is greater than or equal to the quota q. This example says, well, the probability of x being greater than or equal to 3, for example, is the same as 1 minus the complement of the probability of x being less than or equal to 2. The complement of less than or equal to 2 is greater than or equal to 3. That's the key for this formula. It's 1 minus, using the binomial distribution function in Microsoft Excel. It's going to be the quota minus 1. That's the B5 with the dollar signs, means absolute positioning of the quota cell, minus 1. And A9 is the n value in the particular row that's relatively referenced relative to each of these calculations here. And B3 is the probability of success, and the last parameter, true, is what gives you the less than or equal to, as in this example here. That's a cumulative probability. So this formula right up here, and make sure you understand that there's a minus 1 there and a 1 minus there. Here's the example that gives the reasoning behind it. Gives you the probability associated with that n and that quota. For looking at the expected values, if we want 3 for a quota, we might stop here and say, well, if n is 4, I'm expecting 3.4. But that expecting, what you're expecting is an average, but the probability of actually getting x greater than or equal to q for that case is 89%. It's not 97%. So you have to keep going to get 97%. These probabilities are increasing, and as you look down, here's the first one. that meets the criteria, the confidence of 97%, and it's when n is 5, and the expected value is 4.25 there. So 5 is the value of n that you'll have to use to get a quota of 3 successes with a confidence of 97%.